a presentation of Chapter 3, Section 5 in the 7th grade textbook entitled Solving Equations Containing Decimals. Now, even though we've jumped over pretty much the whole chapter, that's a chapter we've already seen. And all we're doing is going from solving equations that just had integers to now solving equations that contain decimals. That doesn't change any of the processes. All it does is it changes what we're actually solving. So you're still going to see positives and negatives involved here, but now they're going to have decimals involved in the mix. We're still going to have those variables on the left side of the equal sign. We're still going to end up moving all of our numbers to the right side of the equal sign. We're still going to be able to flip the sides whenever we need to. And whenever I need to send something to the opposite side of the equation, as in the other side of the equal sign, I'm still going to do the opposite. The only thing that has changed, and I mean the only thing that has changed, is there's decimals here. Everything else is exactly the same. So let's look at 1a, solving n minus 2.75 equals 8.3. Well, again, if we go right to our rules, we know that that variable n is very good, because we know we want variables on the left side of the equal sign. So he's good. 8.3 is also good, because he's a number and he's on the right side of the equal sign. So he's okay. The only troublemaker we have here is 2.75. 2.75's got to get out of the way, so we're going to move 2.75 by adding 2.75 to both sides of the equation. Why? Well, remember, our goal when we move things is to do so by doing the opposite. So when I add 2.75 to both sides, over here I have minus 2.75 and plus 2.75. Those are going to wipe each other out and just leave them in my variable n. That's always how we know we've reached the final step, is when all I have left on the left side there is my variable. Over here I've got 8.3 plus 2.75, which is 11.05, and that's my solution for n. We can check this because 11.05 minus 2.75 is 8.3. Since the other side says 8.3 as well, my equation is in balance because the left and the right side say the same thing, which means I solved this correctly. All right, now B goes to just a question that has addition in front of it, but again, it doesn't change anything. It's still solving an equation. We've got A plus 32.66 equals 42. So we've got a variable on the left and a lonesome number on the right. So the only thing that's in the wrong spot is 32.66. He's a number, he's on the left, but he belongs on the right. So I've got to move 32.66. Well, again, I'm going to move that by doing the opposite. And the opposite here is going to be to subtract. Again, how do I know that? Well, 32.66 has a big old addition sign in front of it, so that would imply that the opposite is subtracting. Also, when I subtract 32.66, that's going to make these two things disappear and just leave me my variable a. If I add 32.66 and then I subtract it away, that just leaves me a. Over here I've got 42 minus 32.66, which is 9.34, which is my solution for a. We can check it because 9.34 plus 32.66 is 42. Since the other side says 42, the equations check and we are in balance. All right, now we go from questions where we had to use the addition and subtraction properties down to questions where we had to use the multiplication and division properties. Here's x divided by 4.8 equals 5.4. Well, again, we know we want to keep those variables on the left. So x is good, and we want to have numbers on the right. So 5.4 is good. The only thing that's not good there is the 4.8. 4.8 is going to have to move. Well, notice this question right now says I'm dividing by 4.8. I have to do the opposite, which is to multiply by 4.8. So I'm going to multiply both sides by 4.8. And again, the way you show that correctly is to show some giant parentheses that I'm multiplying both sides by 4.8. Notice here, this shows that I'm dividing by 4.8 and then multiplying by 4.8. Those are going to cancel each other out and leave me, my friend, the variable x. Well, that's good because remember, our goal in solving these is to keep that variable all by itself on the left side. On the right side, I've got 5.4 times 4.8, which is 25.92. And we can check that to know that that is the answer by dividing. 25.92 divided by 4.8 is 5.4. Since the other side says 5.4 as well, we know our equation checks, and so our solution must be valid. Here's 9 equals 3.6 times d. Well, right away we should detect that there's something a little bit awry here in that the variable is on the right side of the equal sign. The variable's not supposed to be on the right side of the equal sign. The variable's supposed to be on the left side of the equal sign. So this is one of those times I'm probably going to use that flip rule that I have in my back pocket there, and I'm going to invert the left and the right side of the equation. I'm literally going to flip those two guys around and write 3.6d equals 9. All right, so now let's jump into our rules. My rules say to keep variables on the left. Well, I do have variable d on the left, so he's not going to move. And my numbers say to keep my rules say to have numbers on the right. Well, I do have the number 9 on the right side of the equal sign. So the only guy I have to look at moving here is the 3.6. I'm going to move 3.6 by doing the opposite, which is to divide. So I'm going to divide both sides by 3.6 here. Realize that this says 3.6 times d, so that's how I know the opposite is to divide. Over here, the 3.6 cancel out, and notice what happens. I'm just left with variable d. Here I've got 9 divided by 3.6, and even though it's the opposite order of how it's written here, notice that's exactly what they're doing here, and they're solving this, and they're getting 2.5. D must equal 2.5. We can check this by going back and changing d into 2.5. 3.6 times 2.5 here would give me 9. Since both the left and the right side say 9, that means our equation checks. All right, let's go ahead and take a look at the next question. It's a word problem. It says a board game box is 2.5 inches tall. A toy store has shelving space measuring 15 inches vertically in which to store the boxes. How many boxes can be stacked in the space? So the first thing they do is they call out the information from the question in step 1 there. And they say each board game box is 2.5 inches tall. And then they recognize that we have 15 inches of shelving space. The total height of the boxes then is equal to the height of one box times the number of boxes. And since we know how tall the shelf is, we can write an equation, and they decided to let b represent the number of boxes we can put on that shelf. So they wrote 2.5b equals 15. 2.5 inches per box times the number of boxes, b, has to be equal to 15, which is the maximum amount of space we have available on the shelf. So we're going to end up solving the equation 2.5 times b equals 15. All right, so here is the solution now being worked out. Notice they've got 2.5b equals 15, which is a mighty fine equation. Why? Variable b is on the left. That's good. He should be on the left of the equal sign for us to solve. 15 is a number. He's on the right side of the equal sign. Well, numbers belong on the right side of the equal sign to solve as well. So the only troublemaker here is that 2.5. 2.5 is what's going to have to move here. How am I going to move 2.5? Well, right now this says I'm multiplying by 2.5. B is being multiplied by 2.5. So in order to move that, again, when I want to move something to the opposite side of the equal sign, I'm going to divide. So I'm going to divide both sides by 2.5, which is what you see here. I have b just left by itself then because 2.5 divided by 2.5 goes away. And over here, I've got this should say 15 on the top. 15 divided by 2.5. 15 divided by 2.5 changes into 6. So 6 boxes can be stacked in the space. They estimate at the bottom there by rounding 2.5 off to nice 3 and saying 15 divided by 3 is 5, which we know, since my answer is pretty close to 5, my answer of 6 makes sense in context. All right, let's go ahead and finish this up by looking at the check it out examples. 1A there, question 1, solving a plus 27.51 equals 36. So we want to keep variable a on the left side of the equal sign. He is. We also want to keep the number 36 to the right side of the equal sign. Why? Because numbers belong on the right side of the equal sign. So we see our one problem here is 27.51. He's a number. He's on the left side of the equal sign, but to solve this equation, he's got to be on the right side of the equal sign, so a can be all by himself on the left there. So, as far as moving 27.51 goes, notice that's got a big old addition sign in front of it. So I'm going to do that by subtracting. I'm going to subtract 27.51 from both sides. Remember, when we take it off one side, we have to do the same thing to the other. We add it to one side, we have to do the same thing to the other. If we multiplied one side by something, we have to do the same thing to the other. So, I've got this 36 minus 27.51, which is the real meat and potatoes here. That's 8.49. On this left side, I'm just going to be left with a, because plus 27.51 minus 27.51 cancels each other out, and a must equal 8.49. We can check it. We can go back here and change a into 8.49. 8.49 plus 27.51 does make 36. Since the other side says 36 as well, that means our equation checks. Our equation is in balance. Number 2, 9 equals 2.5 times d. Well, I want to go ahead and flip this around here because that's written the wrong way, in the wrong order. Why? Because the variable is on the right side of the equal sign. I don't want the variable on the right side of the equal sign. I want the variable on the left side of the equal sign. So I'm going to invert this guy and write 2.5d equals 9. Okay, so let's go ahead and solve that out now. We know we want to have our variable on the left, so d being on the left side of the equal sign after I flipped is a good thing. We want numbers on the right, so having 9 on the right of the equal sign is also a good thing. So now it's just a matter of me solving by moving 2.5 out of the way. Why? Because he's a number, and numbers belong on the right side of the equal sign. So I'm going to divide both sides by 2.5 here. And when I take 9 and divide by 2.5, the result is 3.6. So d must equal 3.6. We can check it because we'd say 2.5 times 3.6 is 9. Since the other side says 9, the sides are in balance and the whole thing checks. Number 3, the final question, another word problem, says a canned good is 4.5 inches tall, and a grocery store has shelving space measuring 18 inches vertically in which to store the cans. How many cans can be stacked in the space? So, 4.5 inches tall per can. So if we were saying there's 2 cans there, and I said find the height, you'd write 4.5 times 2. If there were 3 cans there, and I said find the height, you'd do 4.5 times 3. If I don't know how many cans are there, that's what we're figuring out, I'm going to write 4.5 times, pick a variable, let's go with C for cans. So 4.5 times the number of cans has to make my maximum height, which they told us here in this second line is 18 inches. So 4.5 times what number is 18 is what we're solving for. All right, well, notice that's actually set up pretty nicely because we do have a variable on the left side of the equal sign, and we have a number on the right side of the equal sign. So the only real troublemaker here is 4.5. 4.5 is going to have to move. Notice right now it says that I'm multiplying by 4.5. I'm taking C and I'm multiplying it by 4.5. Well, if that's a number and he's going to the opposite side, I'm going to move him by doing the opposite, which is going to be to divide. I'm going to divide both sides by 4.5. When I take 18 and divide by 4.5, that's going to give me my result that you see, 4, as in C equals 4, or there's 4 cans stacked in that 18 inches of space in context.